All right, what is up, everybody? We are doing another Leetcode problem, least number of unique integers after k removals. Given an array of integers r and an integer k, find the least number of unique integers after removing exactly k elements. So basically, you want to remove numbers and you want to have essentially as many, bless me, as many duplicates as possible. So yeah. I guess we'll just get right into it. Oh, I guess it went all the way up. It didn't let me go down. Okay. If the length of array is less than k, or less than or equal to k, you can just return 0. Because if you have to remove, let's just say 5 elements out of an array with 4 elements, well, you got 0. You got to remove 5 out of 5, you got 0. So yeah, pretty simple. So we're going to use a dictionary to keep track of the counts of every number that we have. So for num in array, if num not in dict, then we do dict num equals 0, not 90, 0. And then regardless if it was in there or not, we just got to add 1 to it. Now we've built our dictionary, right? Which with every number and the number of times it shows up. So now we create a min-heap because we want to remove the smallest numbers first, right? So for number and amount in dict.items, whoops, double registering keyboard, back at it again. So for every number and amount that we can get from the dictionary, we want to do a heap push onto the min heap with amount first, because that's what we want to sort by, and then the number, because if they're the same number, or no, if they show up the same amount of times, it doesn't really matter what number we remove. So we'll just do that. And so while k is greater than 0, which means we have more numbers to remove, right? And the length of the min heap is also greater than 0, which means we have numbers to remove, and we need to remove more numbers, and we have numbers to remove, right? If we have that, we will extract the amount and number from min heap by performing a heap pop, right? And afterward, then we're going to do k minus equals amount. So basically, like for our dictionary here, we would have 4, 1, 5, 2, right? So here we would get 1 and 4 because we have, and then so we remove it. So it would be k minus 1. So it'd be 0. And so now we just have one number left, right? And we already have our solution. Now for this, it would be like 1, 2, 2, 1, 3, 3, and 4, 1, right? So it'd be, so the order would be something like 1, 1, 4, 1, no, sorry. 4, 1, no, 2, 1, 4, 1, 1, 2, 3, 3, right? And then, so we would pop off the 2 first, and we'll subtract. So that's minus 1, right? So now k is 2. Now we remove the 4 and minus 1. So that's k is 1. So now 1, we have 2 of them, so we minus 1 of those. Boom. We have 1. We still have 1 remaining, and then this, and that's why it's 2, right? So we'll be able to remove it all. And so you might have noticed, like, hey, for this question, it doesn't actually quite solve the problem, because we would have popped off the 1, but our k goes into the negative, right? And that's a good catch, because we'll just get a length which is equal to the length of min heap, right? And so we'll just return length if k is equal to 0, right? That makes sense, because if we've removed exactly the amount of numbers, then it's 0. Otherwise, it has to be negative, right? Because if it's greater than 0, we would still be in this loop, unless it's like out here, right? But if it's out here, okay, I guess it's if it's greater than or equal to 0. Because it's possible we leave this loop if this is greater than 0, right? It's just that this is equal to 0 or negative or positive. This could be positive if this is still 1 or higher, and then we don't go in here. So basically this, we will keep going. We'll return length, right? And otherwise, then you'll return length plus 1. Because if we go into the negative, that means we removed too many numbers, and then so we have to include the number that was just removed, right? Which is just what we popped off, so it would just be plus 1. Yeah, I think because if our length of this is 0, and then it passed the check, that means that would still be true. Yeah. So that is it for the problem. And yeah, let us submit the answer. Yes. Boop. And the answer is correct. Yeah. Yes, thanks for watching. Oh yeah, I didn't mention it, but like this is still using the top K values. I guess you could do you could theoretically, nah, you can't really. For this question, I think you have to push everything onto the array. I was going to say maybe you can like not push some of the bigger numbers, but I think that wouldn't really work out too well, because since you're trying to remove all the small numbers first, it's really hard for you to gauge whether or not you have hit like one of the numbers that just don't go in. Yeah. So yeah, this is how you would do it. Yeah, with that being said, thanks for watching.